I am so grateful you're all here. Thank you for sticking around through the last day of conference. I specifically asked for a dark room, so if you want to take a little nap, it's okay. I won't be offended. So I'd like to invite you to think of a map. Not just any map, but one that has some meaning for you. Maybe it's a subway map from that city you've always wanted to live in, or a backcountry trail map from a hike you took once. A made-up world you read about in a novel. A road trip you took back before Google told us everywhere to turn. When I think of maps, I think of the room I had when I was growing up. My father had collected 20 years of National Geographic magazines, and about 3 or 4 times a year, they put a map in the magazine, and he had collected all those maps, and he used them to literally wallpaper my room. So I grew up in a room covered with maps. And I would lie there in bed at night, or I'd be at my desk procrastinating from work, and I would look at the coastlines and the waterways, the cities, and I would just notice how vast the world is. It all seemed really far away from my tiny village of Higganum, Connecticut, over in the northeast of the US. I had no idea I'd end up in Seattle. So my name is Jeff Petty-Ross. Here I am in Seattle in 1996. When flannel was stylish for the first time, and I had hair. At this time, you could buy, the largest hard disk you could buy was 8 gigabytes. About 5 years later, I was at a startup where we put together 10 terabytes of storage. It required a multi-million-dollar data center and a robotic tape backup system. It was incredibly complicated. It seemed so powerful. And of course, now today, you can go to Best Buy and get a 10 terabyte hard drive for $500. By 2024, IDC estimates that there will be 24 billion terabytes of data that we have collectively created. What are we doing? Why are we doing this to ourselves? And what I ask for all of us here is, how do we make meaning of all of this? Luckily, there's been another field that's been investigating how to make meaning out of 2D images, two-dimensional forms, for a long time. Painting. This is from about 30,000 years ago. It was found in the Lascaux caves in France. And as much as this is a fairly striking piece, and I don't want to diminish its historical or artistic significance, it's just a couple of colors, right? And all the figures appear in a single plane. There's no sense of depth to what's being drawn here. Now, if we move forward to the 18th century before the Common Era, about 4,000 years ago. This is from what we now call ancient Egypt. You can see the artist tools have definitely advanced, right? There's more realistic color, and you can see human figures, so they are stylistically posed with the torso facing forward and the head off to the side. Just like so many of us like to do with our dashboards, there's also lots of text on here too. All those tiny figures across the top are a narrative describing how a priest and his wife are beseeching Osiris to sustain them in the afterlife. About 1,300 years after this, in the 5th century BCE, the Greeks started trying to figure out how to make perspective work. Because, I mean, it's obvious. I can look to the back of the room and see you all look smaller to me than the people in the front row. You're the smarter ones, though, because you get to leave partway through. But we had no idea how to draw it and make it work. Now here in the 12th century, this is a Song Dynasty watercolor. They had figured out some kind of perspective. This is what they call oblique perspective. Because you'll notice things in the background are behind things in the foreground, but they don't get smaller as they get into the distance. We hadn't figured out the math behind that yet. Oblique perspective was used in Rome and India, Korea, Japan, many places in the world. And I think we can all relate to this struggle of how to make things look accurate, right? How many times have we had something that we're trying to tell a story about and we can't quite figure out how to get the data to line up right, or how to just tell the story in a way that helps people see the world the way we see it? It wasn't until the 14th century that we figured out linear perspective as a species. And it wasn't widely adopted, though, until the 15th century, when a man named Filippo Brunelleschi came up with a killer demo for linear perspective. He had a canvas where he had painted the Duomo in Florence that had just been completed. And he put an eye hole in it, and there was a mirror behind the canvas so you could see the Duomo in the distance. And so you could walk up to the canvas, look through the eye hole, see the Duomo, and back up and see the same image, and realize he had figured out how to do something that had evaded so many of us for so long. And so you can see it in things like this, the Annunciazione by Botticelli, painted later in the 15th century in Rome. At the same time, we had pigments like madder red, indigo, lead white, and ultramarine, broadening the palette of what we could put on canvas for the rest of time. And we continued on this trend toward increased realism until the end of the 19th century, when the realists really were at their heyday. As we can see here in Fin du Travail by Jules Breton, there's a sense of light, of things receding in the distance. We see ordinary, everyday people, not just the people who could afford to have paintings done for them. After 30,000 years of trying to figure out how to capture the world around us, we finally did. And then a group of upstarts in Paris decided to throw it all away. The Impressionists started to work outside studios. They decided they wanted to capture something else about the world. You can see the brushstrokes here. But at the same time, there's a sense of light, of movement, of what people are doing, of time and place, climate. All this captured because instead of trying to capture the absolute realism, the artist decided to just gesture in the direction of truth. This is Monet's Impressions sur les Levants, painted in 1872. Edgar Degas was considered one of the founders of Impressionism. This is his painting, The Millinery Shop. He did not think of himself as an Impressionist. He rejected that label. He saw himself as a realist because he thought he was doing a better job capturing the world than realism actually did. And you can see the choices he made. You can see on the woman considering the hat, she's got sort of pursed lips. And is she thinking about buying the hat, or maybe she's got some pins in her mouth because she's making the hat? But in the foreground, you can see that hat with flowers or cloth or whatever the decorations are on there. And he's just simply suggested what they might look like with a few skillful brushstrokes. And then in the 20th century, the Cubists came along and broke it even more. After he spent all this time trying to figure out perspective, they said, well, what if we just cram multiple perspectives in a single canvas? Here in Robert Delaunay's La Vie numéro 2, which was painted in 1910, you can see something is very concrete here. It's a city, painted from multiple perspectives at the same time. He's taking some of the tricks of the Impressionists to capture a sense of light. Cubism blew open the modern art world and ushered in an era of diversity and creativity. We've never put the lid back on that. So painting first took 30,000 years to figure out how to get realism. And then they said, well, we can start picking and choosing what parts of the tools we've learned we can use. So how does this apply to a conference about data? Well, I think that data has been on a similar journey, where we strive to capture ever more realism, ever more detail about the world. And now we're at a spot where it's time for us to let go of that realism sometimes if we really want to tell a creative story that connects with our audiences. So let's see what our forebears in the world of data have done. This is one of the first spreadsheets that we have. This is from ancient Egypt. It's a record of a month's worth of deliveries. As far as I know, no one has found a crosstab on cave walls yet, but in the first century of the Common Era, the Quechua people in what is now South America and the Andes used quipus like this to capture data. Knotted strings were capturing information about numbers. And they used it for things like accounting, but probably also for scientific advancement as well. Quipus were still being used by the Inca people in the 1500s when their empire stretched across the entire length of the Andes. And they were doing things like advanced agricultural research to find out what crops worked best where. Quipus and similar systems were also used in Hawaii and China and other places around the world. Around the same time the Incas were figuring out something about how to advance their agronomic system, Copernicus was studying the heavens. In 1543, he published this spreadsheet in the middle of a book called On the Revolutions of the Heavenly Spheres, where it captures 60 years of the movement of the sun relative to the Earth. And he proved with this, among other measurements, that the sun was at the center of the solar system, as opposed to the belief before that the Earth was at the center of the universe. Tables of figures and bookkeeping continued to be used for hundreds more years. Here we are in the 18th century. Though it turns out double-entry bookkeeping was actually in use back around the time that we switched to the current era, the Common Era. But for all this time, data collection, as it got more and more abundant, was still slow. It was done by hand. And for the most part, most questions people had could be answered with the data itself. And then in 1979, that all changed. Bob Frankston and Dan Bricklin invented VisiCalc, the first electronic spreadsheet. And with it, they took the Apple II and the microcomputers of the time and transformed them from just hobbyist devices into serious business tools for the first time. Over 1 million copies of VisiCalc were sold. It was the first way to digitize data at a mass market scale. And of course, VisiCalc was followed by Lotus 1-2-3 and Excel, and now we have commodity data spreadsheets in the cloud. And at the same time, in the 70s, databases were possible with the invention of drum storage technology and hard drives. And Oracle and DB2 came on the scene, and now we have petabyte-scale implementations of databases that live in the cloud. So we have more data now than we could possibly use. How many of us have been walking around conference collecting step information this whole time? It's been a very good week. But now it's time, like the realists, impressionists, and cubists, we get to pick and choose how we want to tell these stories, what to apply to create focus in what we want to do. And I think even more, it's incumbent on us to add some beauty to what we do, because we want to draw in our audiences. We want to tell stories that actually help them make meaning of their worlds. That's why we do what we do. At least that's why I do what I do. So I have a few examples of what I think is really beautiful data visualization, some in Tableau and some not. This was done by Skylar Johnson a few years ago. And the reason I want to pull up something from a few years back is, first, I love this. It's every time a spell was muttered, flicked, or yelled in the Harry Potter books. This has been featured in such tech audience publications as Mashable, Cosmopolitan, and Teen Vogue. It has gotten 450,000 views so far. And what I like about it is that Skylar did not take a realist approach to telling the story. He took an impressionist approach. He's just gesturing in the direction of the truth of the stories. Now, he could have done a crosstab of spells. It would have been more complete. And to tell you the truth, crosstab does give more context, right? I can see what was going on around this. Sometimes those facts are important. But the understandability and the overall story and certainly any sense of beauty is really gone. You could have done a bar chart. I get more information here. I see which spells were cast the most still, but I don't know the context of when it happened. And it certainly is not as beautiful. This informs, but it doesn't engage in the same way. It's not something that captures the imagination like this does. Skylar's sense of imagination and his creativity brought his story, brought the Harry Potter stories to life in a new way, in a beautiful way. This is a different pile of text. This is a tide chart from the San Francisco Bay. Now, if I were piloting a ship that had a deep draft, I'd want this kind of detail to make sure I did not run aground when navigating through the bay. However, there is a more interesting way, I think, to tell the story for other people. In San Francisco, there's a beautiful interactive science museum called the Exploratorium. If you get to that city, I can't recommend going there enough, no matter what your age is. And in one room, they have this. It's called tidal memory. It sits in a room that looks out over the San Francisco Bay, and out of a literal ocean of data, they've decided to capture exactly 24 points. The last 24 hours of tide measurements taken directly from the San Francisco Bay. So in this room, you get to see the weight of the water. You're invited to walk around it and experience this thing that is this magical interface between the ocean and the sky and how it lives and breathes. It's really brought to life. Another example of beauty in data visualization. This one was created by Georgia Lupi and Stephanie Posavec. It's published in their book, Dear Data, which is also wonderful. Georgia was here at conference this week. Georgia and Stephanie sent each other 52 postcards over the course of a year, once a week, where they chose to measure something out of their lives and tell that story with an original data visualization they created by hand. This one talks about a week of laughter in their lives. Now, they could have captured the same information with a line graph or a histogram, but this gets at the idea of the spark of joy that comes with laughter. It blooms and pops on the postcard as each of them tells the story of how many times and when and how they laughed throughout the week. And of course, maps are visualizations as well. On top of all those maps that my father wallpapered my room with, I had this hanging in my room as a child. It's a map of the universe, starting with our solar system in the bottom right and zooming out 4 times to show stars, then galaxies, then galactic clusters, and then the entire expanse of the universe as we understand it so far. I would study this thing for hours, memorizing acronyms like NGC, and trying to understand the scope of all of creation, because I think it's so beautiful. There's so many ways to tell stories about data in a beautiful way, and they just draw you in, don't they? So, what can we do as data scientists, as people who create dashboards? How do we create beauty? How do we get more creative with our work? Well, it turns out, one thing I learned, one of my colleagues, named Amanda Page, she's got an MFA in fine art. She was a painter. She worked at the Seattle Times, did data infographics for the newspaper for a while. But I got really curious, like, how do you actually get good at painting? And one of the things she showed me was the most mundane thing ever. She showed me some of the early exercises that they did, and it was, imagine a series of cursive lowercase e's. And what they would have to do for homework is just copy those things over and over and over again. But what they were doing was not just copying it, but how can you get every single E the same shape, every single loop the same height, the crossover to happen in the same way, the same spacing between them every single time? It's just a matter of, I mean, not just, I don't mean to belittle it at all, but practice is such a big part of it. So I'd like to encourage all of us to iterate toward more beauty. We don't need to be trained fine artists. This cow captures a sense of something immediate that reaches to us from across millennia to tell something of a story that we begin to tell ourselves. So, how do we get creative? So for the rest of the talk, what I'd like to do is I'm going to do some demos and pull up some resources, share some ideas of how I introduce creativity into the work I do, and it's hopefully something you can pull away and get something from as well. I'm going to be throwing out lots of words like Pixabay and Unsplash and all these different tools and resources. You're welcome to try to capture them as we go by. I also want to let you know I have a slide at the end with names of everything. And from the conference site after the conference, I've published a PDF so you can download links to all the resources as well. So if you just want to sit back and relax, you can do that. So the city of Las Vegas, like many of the big cities, has published lots of data. So I downloaded 30 years of business license applications from this website last week. And I found some interesting stories, or at least one interesting story that I wanted to share with you. So I'm going to bring it up now in Tableau, and let's take a look at it together. Well, first, over 30 years, how many business licenses have been applied for anyway? I'm going to go ahead and drag that measure out and drop it on columns. And when I do, we'll see it's been 97,000 business licenses have been applied for. Well, who's applying for them anyway? I mean, Las Vegas has some fairly famous industries. I'm going to take category group and pick it up and drop it on rows. And we can see that personal services, housing and lodging, and retail make up the lion's share, actually. There are 51,000 rows, a little bit more than half the data for just those 3 categories. And I was a little surprised to see that gambling and gaming is way down here with just 1,600 licenses. Now, what we could do is tell some other parts of the story. Like, I got curious which licenses survive over time, because they have data in there about when the licenses were terminated for different reasons. They expire, they get canceled, and so forth. So I'm going to turn this into a scatter plot where we can compare the two measures. I'm going to change it into a shape plot first, and then we'll take category group and move it on to details. So we're going to keep one circle for every group still. They're just all in a line. And I'm going to spread this out on my canvas by taking the number of terminated licenses and putting that measure on the other axis. Now, as we look at this, we can see those 3 high volume license categories are still there. And most of the licenses fall along this trend down here. There's a similar proportion of canceled or terminated licenses for each of these categories. And then there's this outlier out here. Alcohol, tobacco, and marijuana, for some reason, have a much higher proportion of canceled or terminated licenses. I'm sure there's an interesting story here. So how can I draw people in to look at this? Well, one thing I'd like to do, when I have taken painting classes, and I am not a proficient painter, I've been admonished that I should fill the entire canvas with color. When people first begin to paint, we tend to just paint the subject in the middle of the canvas and leave all this white on the outside. I think the same is true of some good dashboards as well. So what I want to do is go find some pictures to include. So I'm going to go to Pixabay. If you've ever done a search for Google Images, you know that often the images are small or copyrighted. What Pixabay has, and I'm going to type in Las Vegas and search, is high quality, large images that you can include in your dashboards. Now in this case, what I'm looking for is something that can sit on the canvas behind my story. What I'd like to do is get something that can actually help tell the story without taking it over. So as I look through these and I see some very high contrast, brightly colored images, I'm not exactly finding what I want to get to out of this set. So there's another site I like to go to. I'm going to switch to that one now. Unsplash. Unsplash and Pixabay are both very similar business models. People who want to build their business in photography publish images for free. So what's going to happen here when I search for Las Vegas is I'll see a different collection. And I find that Unsplash and Pixabay just tend to have slightly different collections. And again, I can see some fairly iconic images of Las Vegas. This one shows some promise. There's a big open space here where I might be able to tell a story. And I'm going to scroll through a little bit. You can see some of these. Unsplash tends to be a little bit more artistic or artsy in some ways. I'm going to look for one in particular which I saw that really drew my attention. It's not the bunny. This one here. What I like about it is a couple things. One, it's got that big open space, a place to put the scatter plot to tell my story. And it's also clearly Las Vegas. For people who have been here, you can see the light coming up from the Luxor next door. But I also like the sense of loneliness of the one person standing looking out over the mesa. This idea that perhaps this can suggest something about why licenses were canceled. So I'm going to go ahead and download this image. And when I do that, Unsplash is going to give me this. It's going to tell me something more about who made it and also suggest that the right thing to do is give them credit. So I'm going to remember that, photo by Isaac Davis and Unsplash, and we'll come back to that later. So now I'm going to go back to Tableau and let's start building a dashboard with this as our background. So I'm going to create a new dashboard in our workbook. And down here in the lower left, I'm going to grab the image object type and pull it out and drop it on my canvas. Tableau asked me to pick the image, so I'm going to say choose. Grab that photo we just downloaded. I'll say fit image, so it'll stay inside the container. Now I mentioned my painting teachers have told me to fill the canvas, so we haven't quite done that yet. Conveniently, I happen to know, I'm very intuitive this way, that 1348 by 900 pixels will probably work really well. Obviously, I took some time figuring that out, just took a few iterations. But we still have a border around this, and it's not because I didn't choose exactly the right numbers, it's because Tableau, for building dashboards by default, and most of them have white backgrounds, it's nice to have a little space around it, a little breathing room. It's a good design principle. But I want to get rid of it in this case because I want that picture to fill the entire frame. So I'm going to switch to the Layout tab up here. And you can see the photo object has this thing called outer padding on it, 4 pixels of it. So I'm going to take that 4 and reduce it to 0, and you can see the picture move to fill up a little bit more space. As I zoom back out, there's still space left around the edge of this. Well, it turns out the photo container is inside another container, and that one has 8 pixels of padding in it. And when I remove that, now our image fills the canvas entirely. Those padding tools are really useful when you're trying to position things around on the canvas to get them looking just right. Now that I've got the photo filling our canvas, I'm going to go back and grab that scatter plot we made. I'm going to add it on. I'm thinking I'm going to put the scatter plot over here, and maybe we can add some text over here that tells a little bit of the story that we're telling. So if I'm putting the text on the left, I can remove the title from this. And now I can take the scatter plot itself, and that white is really stark against the background. So I'm going to choose Format Shading. And for the worksheet, I'm going to choose None. And that lets that image show through. And I think it looks really pretty. Those lines are way too bright, and the text is way too dark to read. So we need to fix that. And the other thing I'll say is actually, if I go back to this scatter plot now and try to edit it with a transparent background, when I go back to the sheet, Tableau is going to treat it like a white sheet, so it's going to make it very hard to tell what color I want to use. So for now, I'm going to go ahead and make the background color of this not transparent or none, but I'm going to choose a dark color, and that'll let me fix up the formatting here on the sheet. But instead of spending all my time doing that with you here, I'm just going to fast forward to a spot where now I've lightened up the grid lines and made the text a little bit more visible. We're basically where we left off. Now, there's a couple other things I'd like to do with this. One, there are those three clusters of points, right? There's the high volume licenses, there's the lower volume licenses, and then there's that one outlier out there, the alcohol, tobacco, and marijuana. So I want to call attention to those three different groups. I'm going to go back to the sheet now, and I created groups out of those marks already, so we didn't have to go through that here together, and I called it category clusters. I'm going to pick that up and drop it on color. And when I do, we'll see we have three different colors. Now, this is the first three colors Tableau will put on every single categorical palette: blue, orange, and red. I'd like to pick something that actually fits in with the picture we already have, though. So going back to the dashboard, how can I pull out some of these beautiful colors that are showing up from the Las Vegas Strip and use them? Well, one tool I like to use when I'm building palettes is Adobe Color. I've got that here in the browser. And you can see I can build a color wheel by choosing colors and dragging things around, and this is applying an algorithm and helping me choose some related colors. Now, for data visualization, I don't want the colors all so close to each other, because I want the marks to stand out from each other. And in this case, what I'd like to do is build from that image I already have. So I'm going to choose this option here on the left, Extract from an Image, and it's going to ask me to pick a file, so I'm going to go ahead and grab that photo again. And color will try to pull out some colors it sees in there, what it sees as the dominant colors. And it has some automatic algorithms too, where it will try to pick them out. But none of them are really picking out. It's picking out the really dominant colors here, and what I would like to get is some of the brighter colors, pull out some of the lights of the city. And so I'm going to pull some out manually. Like I noticed there's some really nice bright greens down here, so I'm going to drag this over here and pick out some of those brighter greens, if I can land on them. There we go. And then there's that beautiful gold in some of those electric lights down here. See if I can get a nice warm gold. And then right over here in this part of the strip, there's some lovely purples as well. See if we can grab some of those. There we go. Okay, so now I've got three colors from the image. I can see them together in this palette. Now there are a couple other dark ones, but I think they'll actually work together nicely. They're all similarly pastel. So going back to Tableau, I can pick those colors up and use them in my dashboard. Make my Tableau window a little bit smaller. And I'll start with this blue here, the higher volume businesses. So when I double click in the legend, the edit color dialog comes up, and now I can double click on one of these little squares. When I do that, I get a color picker, so I can choose custom colors, any one I want. I'm going to pick up the eyedropper. That's what the tool that Mac has, or something similar on Windows. I'm going to go ahead and pick up this purple for the higher volume. Another thing I want to call out about how I'm doing this is, some of you, if you've done web design or other kinds of screen-based design before, you're probably familiar with RGB, red, green, blue colors. But when I'm picking colors to use in something like Tableau, I like using HSB or HSV, depending on what it's called, where you have hue, saturation, and brightness, or value. Hue means that it's going to stay on roughly the same color, and I can vary how light it is or how colored in it is by dragging the lower two sliders, which is very hard to do when working in a red, green, blue color space. In this case, that seems like a pretty good purple that's going to show up in the background, so I'll leave it. And again, I'll double click in this red, and I'll use the eyedropper to pick up a different color. And I'll double click on the orange, choose the eyedropper, and pick a third color. Now this gold, I think it might be a little bit too dark actually to show up, believe it or not. So I'm going to move it a little bit more toward the orange, a little bit more saturated and a little bit lighter. All right, and now we've got these three colors which match in with the rest of the image on the dashboard. We're off to a good start. Now what I'd also like to do though is, those are all circles. I could go into Tableau and assign a shape palette to help them stand out from each other more. So I could take category group and drop it on shape. But that's just a bunch of random shapes. And these businesses actually have meaning, right? This here is retail. Well, retail doesn't really map to an X in my mind. And alcohol, tobacco, and marijuana isn't necessarily square. So how do we create meaning from that? Well, if I want to use custom shapes, I like going to the Noun project. The Noun project is a giant collection of icons that you can license for a small fee or use for free with credit. So service was one of the categories we had. So I'm going to type in service and press enter. And when I do, you'll see the Noun project searches through its catalog of icons and brings up a collection that goes on for quite a while. Now, as I look at these, there's a few things standing out to me as a designer. One is they have different visual styles. The weight of the line varies from image to image. Some of them are filled in and some of them are just outlines. And just the nature of the shape, some of them are more naturalistic and some of them are iconographic. So as I'm building out a palette of shapes to represent all these businesses, I want to look for icons that are kind of similar. I kind of like the style of slightly thicker line drawings. I think it shows up very nicely in Tableau as well. So let's see if I can get one that looks good for service. So for example, I could pick maybe this one, for example, for service. This one may not be ideal because it's got three different shapes, might be confused in the scatter plot, but I'm just going to move forward with it for now. Now when I choose get this icon, it's going to give me two choices. Pro download or basic download. Pro download says $2.99 for a royalty-free license. If you haven't licensed art before, you're probably wondering why is it $3 if it's free? What that means is you can buy it once and use it forever and never have to pay for it again. A royalty is a fee you pay for every time you use something. In this case, I'm going to go for the basic download, which is free, and it just says what I need to do is attribute the creator of the icon when I use it. And so we'll come back to that and do that later too. When I choose continue, it gives me two choices, PNG or SVG. These are just two graphics file formats. SVG is a vector graphic format. It scales beautifully well. Unfortunately, Tableau does not support SVG. So we'll use PNG, which works also quite well for what we're going to do. I clicked on that, and the file downloaded down here. And when I open the file, you can see we have the icon along with the credit down here in the corner. Well, I'm going to use it at a small size, and the way the Noun project licenses things, if you use it small enough, you don't need to include that text as long as you put it somewhere else. So I'm going to choose this and crop out that text, and I'm going to save it someplace in particular so that Tableau knows where to find this shape. So I'm going to call this service, and I'm going to put it in a folder in my Tableau repository. Let's make this a little bit bigger. There's a folder in your Tableau repository called Shapes, and inside there you'll see more folders, and I've created one called Business Types. So I'm going to open that, and you'll see I have a collection of other icons here. So I went to the Noun project before and got all those. I wasn't going to torture you with watching me download 16 different icons. And here in Tableau now, I can go into by clicking on the shape drop target, bring up the shape dialog, and it asks me to pick the palette I want to use of shapes. And all the built-in ones in Tableau are there, but also you see business types, that folder that I created inside the shapes folder in my Tableau repository. When I choose that, I see the images loaded here. You'll notice, though, the one that we just got is not there because Tableau loads the shapes just once when the app first boots. So if I click Reload Shapes, it'll actually go ahead and pull that in. Now, one trick I used is I named the files in the shape folder in the same order, same alphabetical order as the categories appear here in this list. I realize it's a little hard to read. But this means when I assign palette, Tableau will automatically assign them in the same order in the folder as they appear in the list. which is a shortcut to making that a much simpler process. So now when I click OK, it applies my shape palette, but it's a little tiny, so let's go ahead and click on the size drop target, and we'll make those a little bit bigger so we can see them and understand them better. And now when I come back here, the story is starting to come together. I can get a sense of what these might be. There's something about booze going on up here, and retail and lodging and service are going on out here. Now the last thing I want to do is add some of that text. I'm going to fast forward through that to here, which is where I finished up with this dashboard. I added some text that begins to tell the story, points in the direction and invites more exploration. But more critically for what I want to talk about today, it also includes attribution for everything. Where did the data come from? Who created all the icons that we used? And also who took the photograph. I think it's really the only ethical choice to do to attribute things like that. And that's another challenge I have with using a service like Google Images, is often not only are they copyrighted, so it's illegal to use them, but also it's hard to know who actually created them. So, altogether, I gave you some ideas about how we can actually add some more beauty, how we can add color, how we can add images, how we can add shapes into our dashboards. Now, one more thing, actually I want to go back to Tableau one more quick moment, because as we're adding custom colors, one of the challenges we have there is that 10% of men and a slightly smaller percent of women have some sort of color vision deficiency. So 10% of men have trouble distinguishing reds and greens at some level. Now, I have normal vision, but there are tools that can help us, those of us with normal vision, understand what the world looks like to our colleagues that have color vision deficiency. One of them is Color Oracle, which I've got running on my Mac here. And you can see it lets me simulate deuteranopia, protanopia, and tritanopia, 3 forms of color vision deficiency. And so when I choose the first option, what it's going to do is take my screen and repaint it as someone who has that kind of CVD might see the world. And you can see the colors that I chose, and part of the reason I made that yellow a little bit brighter is I knew where we were going. You can still see these 3 kinds of colors stand out for someone with the most common form of color vision deficiency. Now there are other options to do this as well. I know that for many of us, we can't necessarily install software on our computers at work, so there's this website, Chromatic Vision Simulator. You can upload a screen capture you get, put it here, and apply different forms of CVD simulations so that you can get a sense of what it looks like. And one more tool I'd like to throw at you is Color Brewer. Color Brewer was created by Cynthia Brewer and her colleagues, and it has a number of ways to help pick sequential color palettes that you can use to build your own color palettes. And it has some interesting options too, like checkboxes for, I'm planning on printing this out on paper, I'm going to photocopy it later, help my colors survive those transitions. So far this has all been about representing the data we have. Now we did omit some things because out of 30,000 licenses we ended up with 16 shapes. So obviously there's a lot of data left out of that picture we just drew. But sometimes the right thing to do is make stuff up. Maybe we don't have all the data, or as my friend Zach puts it, the data is not all in the data. Sometimes the data is in your head, which is an odd way of looking at the world, but Zach is a rather odd person. Geography is a great example of a way that we end up lying with data even if we don't want to. And a single perspective, as the Cubists taught us, don't always tell the whole story. So for example, all 2D maps are projections of a squashed sphere, which is the shape of our world, onto a 2D plane. So this means that every single map is a slightly distorted perspective. Now in particular, what we like to use in data visualization is a Mercator projection like this one. Super convenient because latitude and longitude line up in this nice rectilinear grid. Unfortunately, it also means that things closer to the poles get distorted, right? So Greenland is only 3 times the size of Texas. So I don't think that's 3 Texases. Now, this isn't just true about, or this isn't just deceptive about how maps lay themselves out in a Mercator projection, but sometimes our stories actually do matter in ways that don't map well onto geography. So for example, in the United States Senate, There are 2 senators for every state. Every state is equally represented, but Rhode Island on a map looks far smaller than Texas. So if I wanted to tell a story about what's going on in the Senate, a geographic map and a Mercator projection isn't necessarily the best way to do it. Maybe I want to do something like this, a hex map. So I'd like to take you through how do you actually build something like this in Tableau. And we start with a spreadsheet. So I created this spreadsheet here. What I did is I said, here's how I want to lay out the states in the US. And I just basically laid them out on some graph paper and said, here's how I want my hex to show up. And I created this spreadsheet. And I multiplied them out to create some pixel values. Why? Well, because we can load this back into Tableau. So let's bring it up here and see how we can build a hex map together. So this is that Google Sheet you were just looking at. The Google Sheet is also in the resource list that you can download after the talk. So I'm going to build a scatter plot out of those marks. I'm going to take the X pixel and put them in columns to paint them out horizontally. The Y pixel to spread them out vertically, and then I'll drop state on detail to get 1 mark for each row. And you can see the beginning of the hex map here. Now this is a bunch of circles instead of hexes, so I created a custom shape to get that hex map we want as well. So I'm going to go ahead and choose the shapes palette again. In this case, I'm going to choose a different one, custom. And I have a hexagon here. I also have this hexagon ping available for download afterwards too, if you'd like that. Come out pretty small, still look like circles, so let's make them bigger. And you'll notice they aren't quite tiling right, even when they get next to each other horizontally. We'll get to that in a sec. But this also doesn't look a lot like a map. It still looks more like a scatter plot. So we can go ahead and right-click on the headers and turn them off. And then to get rid of those lines in the background and make it look truly like a map, we'll say Format Lines. And if I remove the grid lines, the 0 lines, and the axis rulers, now we have something that starts looking a little bit like a more abstract map. Now, I'm going to take this map and drop it on a dashboard. And when I do, you'll see that the reason why those hexes are all crashing into each other is the size of the hexes remains constant no matter how big the map is. So the way to make a hex map work in Tableau is twofold. One, you adjust the size of the marks on the sheet, but then also you want to put them into a dashboard container that has a fixed size so that no matter how people resize the dashboard, it stays proportional and tiles well. Now, just to finish telling this story in a more graphical way, when I come back to the sheet, the tiling goes away again. But I'm going to blend this data source with another one, so I can tell the story about the data I have using this layout. So in this case, I went with a very prosaic superstore, but I can take, for instance, profit and drop it on color and start getting one sense of the story. I'm going to take sales and put it on label, and you notice not all the labels appear. Well, Tableau tries to be very careful about not overlapping marks with text, but we can tell it we want to ignore that. First, I'm going to center all the text, both horizontally and vertically, putting the text inside the shapes. And then I'm also going to choose Allow Labels to Overlap Other Marks. And when I do, now I get a mark for every state that has a value. Now, three places, Washington, D.C., Alaska, and Hawaii, have nulls. So let's filter those out. I'm going to drop sales on my filter. And then choose to filter everything that is not null, or that is null. And now we've started building something that begins to look like the hex map we saw. And you can start telling stories this way about data that is best told without being truthful about the geography in one sense, but actually gets better at the truth in a different sense. Now I want to share another example of a hex map. This one is from The Guardian in the UK. This is about the elections that are unfolding in Spain. I believe they just finished. What I love about The Guardian is they've created these hex maps for many major countries in the world, and what they've done is they've tried to get a sense of the proportionality of the vote. And they've obviously added some interesting coloring as well to help tell the story they want to do. So they have made stuff up. This is clearly not how Spain looks, but it is a more accurate way to tell the story from one perspective. My friend Kim Rees created a visualization a few years ago, You can find this on YouTube. It's about gun deaths in the US. And she estimated the number of years of lives lost to gun deaths by looking at average life expectancy of everyone who was killed and adding up all the years that might have been lost. So she made stuff up. She added her own data to tell the story in a more complete way from her perspective. Now, sometimes our data ends up lying on top of each other, right? So many marks are together. I got lots of points on a map that want to be near each other, or I get a scatter plot where things are too close to each other. And I think the pointillists had an idea here because they used patterns to tell stories. So here's something from Georges Seurat, Un dimanche après-midi à l'île de la Grande Jatte. And here, Seurat did not paint any colors directly. He used points of other colors to create a sense of light and shadow and texture. Now in data, we can scatter points a little bit to make meaning that can be obscured. And there's a technique called jittering. When we have many points on top of each other, sometimes some of the meaning is lost. So I'd like to show you another data set in Tableau that begins to demonstrate this. I need to get out of PowerPoint so you can see it too. So here I'm looking again at Superstore. I apologize for the boring data set, but it helps tell the story about jittering very nicely. What I've got here is I've got one mark for every single sale, every single transaction in this database. Now, what you can't quite tell is how many marks are there actually at some of these spots. I can try to drill down a little bit more. So I can go from months down to days, for example, and I can see, okay, I can begin to understand there are some patterns here. There's a lot of zero discount transactions, but also a whole bunch at 20%. But I can't really tell much other than January and February seem a little bit lighter, but what's going on for the rest of the year? Are there any other months that stand out more? So what I'd really like to do is just shake things up a bit, get a little bit pointillist about this, and see if we can make more meaning by adding some randomness. And the randomness I'm talking about in this case is jitter. So looking here, the measure I have in this viz is average discount. So what I'd like to do is build a calculation around that average discount value with jitter on it. So let's edit this calculation and take a look at it together. It's built out of 3 parts. First, here's the measure that we started with, average discount. And then it's got 2 things done to it. First, it's got this random factor. Actually, I did not write down random in the sheet. Random is a function that is not documented in Tableau. What it will do is return a number between 0 and 1, 0.23, 0.57, and so forth. And then I've created a parameter called jitter size. And jitter size is a number that says how much randomness do I want to insert into this. Now, since I'm looking at percent discount, I'm going to change the jitter size in the order of percentages so that it'll help spread it out a little bit. And then finally, the last term here is jitter size divided by 2. Because if all I did was add some random factor of jitter, it would just increase the values. But by dividing it by 2, it's going to spread it out around the original data point. So if I replace average discount with our discount with jitter calculation, and I turn on the parameter for jitter size, you can see jitter size right now is set at 0, so nothing happened when we added that calc. But if I start increasing the jitter size, and remember this is a number that's going to get multiplied by that random factor, 1%, 2%, 3%, 4%, you can start seeing as we shake these things out. Now I need to know that I'm jittering these, that this isn't the actual discount. But without points overlapping each other in an incorrect way much, I can see that actually in September, November, and December, there was more discounting going on. So now I can drill in and understand the data a little bit better. Now there is another technique I'd like to share here too that's not quite as random, but also suggests the data a different way. So I'm going to take jitter back down to 0 for a moment and change the mark type to density. When I choose that, what this does is Tableau puts a semi-transparent mark that fades out from the center each place where there already was a spot. And you can see they start getting a little bit more darkly painted in different places. Now with the default display of density information here, it's still a little bit hard to see, but there are 3 things you can do to adjust the density to see if you can pull the story out that you're looking for. One is in size. You can change the size of the mark, and in this case, it is literally just changing the size of the mark, but then they overlap each other a little bit more, and you might get some more darkness. And also in color, there are two things: intensity, which changes the darkness, and opacity, which similarly changes the darkness, but in a slightly different way. And now I can start seeing some of those same trends in September, November, and December, but you start losing a sense of some of the individual transactions that are out here. It gets harder to spot those. So depending on your application, density and jitter are two different ways to take hyper overplotted points and make meaning from them. There's one more concrete way. So what I did is I showed you a very random way to jitter. It's the simplest way to do it. My colleague Sarah Battersby, also goes by Maps Overlord on Twitter, to give you a sense what she likes. She created this. So this is a bunch of points that all have exactly the same geographic location on the map, but she wrote a little spiral algorithm that, depending on the number of marks, will basically move slowly out in a spiral away from the central point, so you can see all the different data points around each of the marks. Okay, so we've talked a bunch about some different ways to throw color and shape and different ideas at our data, but I still want to encourage us to be really thoughtful about how we do this. Color is a powerful way of how we tell stories with data. Think about it, over all those thousands of years, how we added more and more colors to our palette and our stories got richer and more accurately told. Here on the left, we have something from the South China Morning Post by Simon Scar. Now, the angle he wanted to tell in this story was to get at the scope of loss of life from the Iraq War. You can see what he did. He chose a dark red and made the bars come down to suggest it might be dripping blood. My colleague Andy Cotgreave simply flipped it upside down and changed the color and put a new title on it, and he tells a different story with exactly the same data and exactly the same shape. So our choice of color is an incredibly powerful factor in how we're going to perceive a story. Shape also has an impact. You may recall that for alcohol, tobacco, and marijuana, I chose the image on the left to represent that shape as opposed to the one on the right. Now, if I'd wanted to try to make some suggestion about marijuana and its role in the economy here, I could have chosen the one on the right. The problem is in the data, there are a lot more business license applications around alcohol than there are around marijuana. So while those three are grouped together in the data, I chose the image that actually more accurately represents the underlying information. Something else to be thoughtful about is the level of detail. Now, I don't know about you, but I find this to be an incredibly realistic image of a black-headed gull. It's a photograph taken at a zoo. It doesn't get much more realistic than that. But it turns out if you think about things like etchings like this, there's actually even more detail put in there. In some way, it's hyper-realistic. In both of them, I get a sense of the shape of the animal and the overall coloring, but here there's so much detail put in on purpose by the artist to help with identification and similar ways that a scientist might want to look at this bird. Anatomical drawings do the same thing. If you've ever seen a photo or a video of surgery and compared it to an anatomical drawing of the inside of a person, the anatomical drawings are much easier to read because the artist pulls out the detail on purpose. So with all these ways to manipulate data and tell stories with it, the last thing I want to talk about is being ethical, because we can certainly tell stories in ways that are misleading. Picasso had a great quote about this. I've got a fuller quote that I'm going to read to you. He said in 1923, "In my opinion, to search means nothing in painting. To find is the thing. We all know that art is not truth. Art is a lie that makes us realize truth, at least the truth that is given to us to understand. The artist must know the manner whereby to convince others of the truthfulness of his lies." And I'm sure you can all relate to this, times that you have seen stories brought to life by lies. Now, some of these are not good lies. Please never create a bar graph that does not have a 0 at the bottom of its axis. But sometimes we include all the data in an accurate way, but accuracy isn't necessarily the correct thing. So this is an accurate representation of the average global temperature in Kelvin. So 0 Kelvin is absolute 0. Nothing gets colder than that. Now the facts are accurate here, but it turns out this is provably the wrong way to look at the data. When it comes to temperatures, anomalies are much more relevant than absolute temperature. Absolute temperature only applies in a meaningful way over very short distances, but anomalies actually give us meaningful readings at the month or year scale over thousands of kilometers. So this is the more accurate way to look at this data, even though it is the exact same data points with just a different axis. So we've arrived together at the end of our journey. I'm going to leave this up for a moment if you want to capture the names of those resources. Also, you're welcome to come back up afterwards and I can pull it up for you. Like I said, this is all available from the Tableau conference website after the fact. So we started today's journey with a map. Hopefully you brought something to mind that was meaningful for you. And we together traveled over the course of 30,000 years of art history, of painting, as people struggle to get more and more realist with our tools. And the parallel trip taken by our forebears in the world of data, bringing us to where we are today, where hyper-realism is pretty much impossible to achieve. So now here we all are, like the painters at the opening of the 20th century. We have all these tools before us about how we can tell our story, how we can pull together creative stories with data and dashboards. So I encourage you to go forth, be creative, use your tools, and tell your stories well. Thank you very much.